Okay, welcome back. This is part 2 of the topic about battery cell that was commonly appearing in electrician licensure examination. I hope you already relaxed a little after watching and digesting the learning and the strategies in part 1. We will continue solving common problems about battery and cell in this part. Let's proceed. Next question is about PEC on storage batteries provision. Questions reads like this. A storage battery supplying emergency lighting and power shall maintain no less than 87.5 of full voltage of a total load for a period of at least blank. Was it 1.5 hours, 2.5, 2, or 1 hour? The answer lies in PEC Chapter 7 Special Condition, Section 7.1.3 Sources of Power, Section 7.1.3.1 Paragraph A, Storage Battery, page 706. It states like this. Storage batteries used as a source of power for emergency system shall be suitable rating and capacity to supply and maintain the total load for a minimum of 1.5 hours without the voltage applied to the load falling below 87.5 of normal. Based from our PEC reading, the correct answer is letter A, 1.5 hours. Actually, it has a follow-up similar question. It reads like this. Storage battery used as a source of power for the emergency system shall maintain a voltage applied to the load without falling below a certain percentage of normal value. What is this percentage? Reviewing the choices and with the support of Section 7.1.3.1a, we already know the answer, right? You are correct. It is 87.5%, which is letter B. The next question came from maintenance. It reads like this. Before storing a lead-acid battery for a long time, the battery should be, what do we need to do? Discharged and covered with canvas, or discharged but the electrolyte is not drained, or keep the electrolyte level low, or discharged and drain the electrolyte before storing. The correct answer is to discharge the lead-acid battery and drain the electrolyte before storing it. Letter D is the correct answer. The next question is, what is a typical output of a lead-acid cell is blank? Since we reviewed this in the introduction, you can spot the correct answer immediately. You are correct. The lead-acid typical voltage output of a cell is 2 volts. The correct answer is letter C, 2 volts. The next question is, a cell supplies a load current of 0.5 ampere for a period of 20 hours. Until its terminal voltage fall to an unacceptable level. How long could it be expected to supply a current of 100 milliampere? Was 5 hours enough, or 100 hours, or 60 or 70 hours? Let's compute. Our solution is to determine first the rating of the battery in ampere hours. Before we can determine how long it will last supplying 100 milliampere, here's the solution. Rating is 0.5 ampere times 20 hours is equal to 10 ampere hour. If the rating of the battery is 10 ampere hours, dividing it by 0.1 ampere or 100 milliamperes, it gives us 100 hours. Our correct answer is letter B, 100 hours. The battery can last 100 hours supplying 100 milliamperes. Similar problem may come out during the licensure exam for master electrician. You need to make sure you get the strategy of the calculation. Our basic question that may be given in the board exam is simple as, what solutions are used in the batteries? It is called what? Is it base? Is it a catalyst? It is a compound? Or it is an electrolyte? That's very simple, right? Of course it is. It is electrolyte. The answer is letter D. Our next question is a calculation again. A battery whose internal resistance is 5 ohms is connected to an external resistor of 10 ohms. The battery terminal voltage is 15 volts. What is the EMF of the battery? We need to find the EMF of the battery. What voltage is it? This is the mental drawing of the problem. We need to find first the total current and then find the voltage drop in the 5 ohms and 10 ohm resistor. Because those are the voltage drop, then we will apply voltage total is equal to voltage internal plus voltage terminal. Here's the solution. Finding the total current is 15 volts divided by 10 ohms equals 1.5 amperes. Since the current flow to be internal also, therefore, EMF is equal to voltage internal plus voltage external, since voltage internal or VI is 1.5 ampere times 5 ohms plus 15 volts. The EMF is equal to 22.5 volts. The correct answer is letter C, 22.5 volts. A very simple question you will encounter is this one. What is the other name for counter EMF? Your choices tells you the obvious, right? It is back EMF, opposite EMF, mutual EMF, or self-induced EMF. That's correct. The correct answer is letter A, back EMF. You're correct. So, another common questions you will encounter is, when charging a lead-acid cell, the electrolytes becomes what? Stronger? Weaker? It's become water? Or it's become stable? Well, what comes to your mind when you charge a battery? Is it gaining charge, right? Therefore, electrolytes become stronger. The correct answer is letter A, stronger. Another question for the typical output voltage is this. 5 carbon zinc cells are in series. The open circuit voltage at the output is blank. Since we reviewed the carbon zinc cell output voltage, our solution is output voltage is equal to 5 cells times 1.5 volts equals to 7.5 volts. Obviously, the correct answer is letter C. That's 7.5 volts. The problem in the battery with internal resistance has a lot of things to manipulate in creating questions that test the mind of the future master electrician in the licensure examination. Here is another question. A battery has a total EMF of 7.5 volts and a total internal resistance of 1.25 ohms. What external resistance will send a current of 2 ampere? We are asked to find the value of the external resistance, right? Here is the simple representation of the circuit. We have EMF of 7.5 volts. We have R internal of 125 ohms. We have 2 ampere flowing in the circuit. We have to find the external resistance RE. Solution. Using series circuits formula, where E is equal to I times R, where the total resistance is R internal plus R external. Substituting the voltage 7.5 equals 2 ampere times closed quantity 1.25 plus RE is 7.5 divided by 2 equals 1.25 plus R external. 7.5 divided by 2 minus 1.25 equals R external. Manipulating, 2.5 ohms equals R external. The external resistance RE is equals to 2.5 ohms where 2 ampere current flow. The answer is letter D. Similar problem may came out during the licensure exam for master electrician. You need to make sure you get the strategy of the calculation. Another problem is finding the charge that flows from the battery charger to the starter motor. It reads like this. A car battery supplies a current of 50 ampere to the starter motor. How much charge passes through the starter in 1/2 minute? We need to calculate the charge in coulombs. Okay? So, here's the solution. We know that coulomb is ampere second. Formula for charge Q is current times time in seconds. Since we have 50 ampere and we have 1/2 minutes or 30 seconds, therefore, charge Q is equal to 50 ampere times 30 seconds, which give us a total of 1,500 coulombs. The correct answer is letter A, 1,500 coulombs. Another simple question that can be asked is, which of the following gases is given off by lead-acid storage batteries? Is it oxygen? Is it hydrogen? Or is it nitrogen or carbon monoxide? You are correct. It's hydrogen. The correct answer is letter B. Another simple question that can be asked is, a battery is rated 200 ampere hour. If it is used to supply a constant current of 8 ampere, how long can the battery last until it becomes unusable? Solution. Since charge Q is equal to current times time in seconds, then time is equal to charge divided by the current. Substituting the values, since we have 200 ampere hour divided by 8 ampere, it is equal to 25 hours. The correct answer is letter B. It's 25 hours. Similar problem may come out during the licensure exam for master electrician. You need to make sure you get the strategy of the calculation. Another simple question that can be asked is, what do you call a cell which cannot be recharged? I mentioned it in the introduction. The obvious answer is, it's primary cell, which cannot be recharged. The correct answer is letter A. Another question that can be asked is, the total voltage and amperage of 4 0.5 ampere 1.5 voltage cells connected in series is what? Solution. 4 units of batteries times 1.5 volts is equal to 6 volts. Battery voltage in series are additive, while the current flow is the same, so it is 0.5 ampere. The combination answer should be 6 volt, 0.5 ampere. The correct answer is letter D, 6 volt and 0.5 amperes. Here is another problem that was manipulated to make our master electrician think. If the current from a short-circuited 1.5 volt dry cell is 25 ampere, what is the internal resistance of the cell? Here's the visual representation of the problem. We need to find the value of the internal resistance Ri. Solution. Since this is a simple series circuit, using Ohm's law, we can find immediately the R internal. R internal is equal to E over I, that is 1.5 volt divided by 25 ampere, which is equal to 0.06 ohms. Our correct answer is letter C, 0.06 ohms, the internal resistance of the battery. You learned so much today. Why not take some problems in our Moodle review app? In our online review for RME, you need to take as many problems as possible to pass the board exam for RME, at least 100 questions per day. There are lots of questions about battery, and I didn't tackle many objective questions here. I hope you will review more on the battery cells. Good luck! For now, you can subscribe in this channel to keep you updated, or you can visit my Facebook page and like us to support the Master Electricians Review. See you in the next topic.